Hey kids, it's Dr. Runs here with your Objective 30 lesson. We are going to begin solving equations. We're going to start with one-steppers, and we're going to focus on addition and subtraction first. Hopefully this is a review lesson for you. However, if it's not, you'll be just fine. We will make sure that we get everyone in the same place so that we are all successful. I'll remind you again though, and I think we said this at the beginning of the unit as well, it's really important that you stay on top of your homework from this point because these next lessons very much so will be building on one another. So it's important that you understand each step. So typically I record these just for students to use at home, but I happen to know that this is going to be used in my classroom as well for an absence. So please feel free, especially to pause this as needed, to rewatch as needed. I do my best in these videos, but they're not all perfect. And every math teacher will teach them differently, and that's okay. This is just what we are doing for now. So, okay, so let's jump in with some vocabulary here. Let's start with an equation. There is a difference between the word equation and expression. An expression is something like this, like multiple terms strung together, right? An equation is when there is an equal sign. It's two equal expressions. There must be an equation, or there must be an equal sign for it to be an equation. If it does not have an equal sign, it's an expression. It's not an equation. And then the solution, it's kind of like saying the answer, but it's not as great to say that in a math class. We say solution, and that just means the value of whatever the solution is, the value of the variable, the value of the letter where you are trying to find its worth. Now we are going to be solving our equations using what's called inverse operations. Inverse means opposite. So we're going to use opposite operations. These are the operations that undo one another. So for example, addition and subtraction cancel each other out. So say for example, if a bank made an error in my favor, which will never happen, they could undo that error by subtracting that money back off. If I wanted to work with a recipe, I could either multiply it to make it a bigger recipe, but keep the proportions so it doesn't taste terrible, or I could divide that same recipe to make it smaller again so it tastes right. But if you're cooking in my house, it's just, don't even try. So let's talk about how to use these inverse operations to find the solution to an equation. We are going to start with very simple equations that no doubt you can do in your head. Not only am I teaching you the rules, however, I'm teaching you the correct steps and a very streamlined way to show your work. I'm trying not to be possessive or nitpicky or crazy about how you show your work, but I do know where we're going this year with this, and I also know what you're doing next year too. And so if you can show your steps in these same exact ways, you will really benefit yourself. Okay? All right, so here we have this equation. X minus 7 equals 4. X is our variable, and X really represents the word what. It's our unknown. What is it? And so really this means what number minus 7 equals 4? Well, you know what that is, don't you? 11. We know that 11 minus 7 equals 4. Now, what if these are really ridiculously huge numbers and you can just rattle that off, right? So we're going to talk about ways that you can do that in more difficult situations. So we are going to do this by using inverse operations to isolate the variable, to get it alone. So we want this x to be alone. It is being paired up, though, with a negative 7. What is the inverse or the opposite of negative 7? Positive 7. Negative 7 and positive 7 zero out. And solving an equation is kind of like keeping a teeter-totter balanced. Not the new modern ones that you guys have with like the safety bubble underneath them. I'm talking about old school teeter-totter that's like a 20-foot board, and if some punk kid jumped off the other side, the other poor kid's going to break their tailbone. So that's what I'm talking about. So if you add 7 to this side, then you must keep it balanced and add 7 to the other side. Just like if you have a balanced teeter-totter, if you add one kid to one side, you need to add another kid of this similar size to the other side. So anyway, negative 7 and positive 7 cancel out. And so we just cross that out. And then we are left with x equals, there's the 4 we started with, and another 7 makes 11, which is what we said it was going to be in the start. So good production skills. Now, especially as this gets more difficult, we need to be able to prove our solutions so that we can make sure that we're being accurate, especially in multi-steppers. So we're going to prove this by substituting. There's no way that word's going to fit on this little line. We're going to substitute the solution into the original equation using parentheses. Please do not be lazy. Please actually use those parentheses because that indicates that that number came from some other place. So we originally had x minus 7 equals 4. Now instead of x, let's say 11. 11 minus 7 equals 4. 11 minus 7 is 4. Yeah, it balances out. So we can say, yeah, this is the correct answer. This x equals 11. Okay, it's very crucial that you show your work. I get that you may not need to show your work here. However, I am not just teaching you how to solve equations by addition, but I'm also trying to instill very good habits for you so that you naturally show your work so that when this gets more complicated, it's all streamlined and easy to understand for both you and me. Okay, so I'm just going to walk you through these equations. You are very welcome to pause this at any time so that you can go ahead to the best of your ability and then play again so that you can check yourself for accuracy. Or if you're not feeling that confident yet, you're very welcome to just watch and take it in, take your notes as we go. You're always welcome to go back and watch it again later too. It's entirely up to you. But I'm just going to just do these problems and talk them through, just trusting that you will do that and pause and rewatch and do all those things as needed. Okay. All right. So here is our equation. It's an equation because it has an equal sign. It is what minus 4 equals negative 6. To find the value of x, we need to isolate it. We're going to use inverse operation. So the inverse of negative 4 is positive 4. What I do on one side, I do to the other. Negative 4 and positive 4 zero out. So we're left with x equals negative 6 plus 4 is negative 2. And we can prove that because by going back, we can say negative 2 minus 4 is in fact negative 6, like so. Now you don't need to do this bottom step, but I'm trying to show my work so that you understand how you can go back and check your work. Okay, let's go to the next. Again, I have x plus 21 is 41. What and 21 is 41? Well, you probably already know that it's 20, but let's show the steps to prove it. The opposite of a positive 21 is a negative 21. What I do on one side, I do to the other. So I'm left with x equals the 20 that we predicted from the start, because 20 and 21 make 41. Here we have a variable on the right side. X is now with a negative 8. The opposite of a negative 8 is a positive 8. And again, what I do on one side, I do to the other. So 20 and 8 make 28. That equals x. Another habit to get into is to always write the variable first, like so. Okay. For this next one, again, the variable is on the right. Sometimes it's difficult to determine if you should be moving the 4 or the 13. So what I do is I draw an arrow to the x, and that helps my eyes narrow in on the side that I'm trying to chip things away on. So I want this x to be alone. So it's with a positive 4. Reverse of positive 4 is a negative 4. 13 minus 4 is 9 equals x. And then what do, guys? Yeah, x equals 9. And we can go back and check our work, plug 9 back in there. 9 and 4, yes, that's 13. Typically, I don't circle my answer until I've gone back to the original equation to make sure that I've done it right. That's just a little habit that I've gotten into that prevents errors, and I do still make errors, guys. Even old people have been doing this for as long as you've been alive. Make errors. And don't let adults tell you that they don't, because that's silly. Okay. Whew, this backside is overwhelming, isn't it? 16 questions, we can do this. Okay, we want this x to be alone. It's with a positive 6. Reverse of positive 6 is a negative 6. Positive 6 and negative 6 zero out. What I do on one side, I do to the other. So x is 2. 6 and 2 is in fact 8. Okay, again, I'll remind you, if you want to go ahead of me, you absolutely can. Here, x is with a negative 7. The reverse of a negative 7 is a positive 7. What I do on one side, I do to the other. And 3 and 7 make 10. Negative 7 and 10 is positive 3. That's correct. Okay, try the first step of the next one. We want x alone. It's with a positive 8. The reverse of a positive 8 is a negative 8. What I do on one side, I do to the other. 9 minus 8 is 1. Of course, 8 minus 8 is 0, so 1 is x. And of course, remember to flip the variable so that it's first. 8 and 1 is in fact 9, so I can be confident with my solution. Okay, try the next one. X is with a positive 9. Reverse of a positive 9 is a negative 9. What I do to one side, I do to the other. Negative 6 is x, or x is negative 6. All these things that I say, what I do on one side, I do to the other, it's kind of like brainwashing you. Actually, it's kind of creepy, right? If I were in class here, we would practice those statements, but as we get going in these lessons, these are intentional phrases that I repeat so that they get burned in your brain so that you remember this stuff long term. Okay, this next line is slightly different here. If you'll notice, I want x to be isolated, but x is no longer positive. So we'll talk about what we do in that case. So my negative x is combined with a positive 8. The reverse of a positive 8 is a negative 8. What I do to one side, I do to the other, and I bring down what's left. But with this x also comes its negative. Before they were just positive, so I can just bring down a positive x, but that's not the case any longer. And then so 12 minus 8 is 4. This looks kind of strange. That's not a solution. Actually, the x needs to be not only by itself, but positive. There's a long way of explaining this and a short way as well. I'll tell you both, and then you can choose whichever makes sense to you. Remember, what you do to one side of the equation, you have to do to the other. So I can make this negative x into a positive x by multiplying it by a negative 1. Negative 1 times negative x is a positive x. And if I multiply the left side by negative 1, then I have to multiply the right side by negative 1. 4 times negative 1 is negative 4. The shortcut is this. If you change the sign on the left, then you change the sign on the right. Okay? And we can sub it back in. Negative 8 minus a negative 4. Two negatives in a row make a positive. I'll write it out. Negative 8 minus negative 4 equals 12. See, I wrote what I subbed in parentheses. Two negatives make a positive. 8 and 4 make 12. And so we can know that that was our solution. Let's try another one in case that was a struggle. Our negative x is with a positive 14. The reverse of a positive 14 is negative 14. What I do on one side, I do to the other. 14 minus 14, of course, is 0. So now I'm left with my negative x by itself, which I can bring down, equals 1. If I want to change a negative x into a positive x, then I need to change my positive 1 into a negative 1. 14 minus a negative 1, or 14 plus 1, is 15. Let's try the next one. This time the variable is on the right side. It's still negative. We'll still subtract off the 6 rather than the 10 because 6 is with the x, not the 10. 6 minus 6 zeros out. 10 minus 6 is 4 equals negative x. Oh, we need to have the variable on the left. Negative x equals 4. We also need to have a positive x. So change the sign on the left, so change the sign on the right. And we can check ourselves. A negative 4 makes a positive, plus 6 equals 10. I'll show you what that looks like. 10 equals a negative 4 plus 6. Two negatives make a positive. 4 and 6 make 10. And that's how you can prove your work. Okay. Feel free to go ahead on the next one without me. Negative x is with a positive 7. Reverse of a positive 7 is a negative 7. What I do on one side, I do to the other. 13 is negative x, or negative x equals 13, or positive x then is negative 13. 7 minus a negative 13, or 7 plus 13, is 20. And so we're good. We're halfway done with this back page. Good job, guys. Hang in there. You can do this. Okay, did you ever wonder if you were going to use what you learned in Objectives 28 and 29? Well, absolutely you're going to use those things. For these next equations, you are going to be combining like terms and maybe sometimes using the distributive property as well. And won't that be fun? Okay, on the left here I have 3 terms. If you need to, you can find a sign, draw a line to the left to separate those out so that you can see which sign goes with which value. Bring down the variable first, so I have an x. I'm going to mark it so I make sure that I don't skip anything. And I have a positive 6 minus 7, so that's negative 1. X minus 1 equals 13. So I just simplified this left side. This is much easier to deal with than that. And now I want to isolate my x. It's with a negative 1. Reverse of negative 1 is a positive 1. What I do on one side, I do to the other. 13 and 1 make 14. 6 and 14 make 20. Minus 7 is 13. That is my final solution. Sometimes when you're combining like terms, it needs to be the variable rather than the constant. So on this side, I'm combining x's. I have 2 x's minus 1x. I only have 1x left. Minus 6 equals 14. And now it's just like the top 2 rows that we did. We went x by itself. It's with a negative 6. Reverse of negative 6 is a positive 6. What I do on one side, I do to the other. A negative 6 and a positive 6 zero out, so I'm left with just an x on the left side. 14 and 6 make 20. 2 20s is 40, minus 6 is 34, minus 20 is 14. Did I say 24 or 34? I meant to say 34. Yeah, okay. Sorry, guys. It's late. Okay, now we have distributive property and combining like terms. Here we go. See how everything builds on itself, right? So it's necessary to understand Objectives 28 and 29 before we jump into 30. So here are the parentheses. The number mushed up against the front is the 2, so it becomes 2x minus 6. This negative x wasn't involved. It comes straight down. And now I can combine my like terms. This time they're variables. So 2x minus an x is x. Minus 6 equals 12. So it looks kind of like the previous question. X is with a negative 6 again. Reverse of negative 6 is a positive 6. What I do on one side, I do to the other. 12 and 6 make 18. 18 minus 3 is 15. Times 2 is 30. Minus 18 is 12. So as you can see, these are getting more complicated as promised. And as I'm showing you all of these steps and how to show your work, it's important that you do that so that your work isn't all over the place and crazy. It really helps everybody out if we can keep it consistent. Also, while we're taking notes, I should have said this from the start. Don't just be writing down the final answer. Make sure that you're writing down all the steps. Even if you think you know how to do it and you'll remember it later, for the sake of notes, please actually do all the work. So here are parentheses here. There are negative 3 groups of x plus 2. So this is our new form without parentheses that we can work with. And now find a sign, draw a line to the left to combine them. Negative 3x plus 2 back is a negative x. Minus 6 equals 9. Again, I recommend that you underline and such to make sure you don't leave anything behind. Negative x is with a negative 6. Reverse of a negative 6 is a positive 6. What I do on one side, I do to the other. Bring down the negative with the x. So if negative x is 15, positive x is negative 15. Negative 15 and 2 is negative 13 times negative 3 is 39. Minus 30, because 2 times negative 15 is 30, equals 9. The end. Oh, but not really. But wait, there's more. Okay. For these next ones, we are going to use multiplication rules of signs because we have 2 signs pushed together with no sign in between. That'd be really redundant, right? And so we multiply them together. So you know that a negative times a negative is a positive. So really this equation is x plus 7 equals 12. And the reverse of a positive 7 is a negative 7. What you do on one side, you do to the other. So you're left with x equals 12 minus 7 is 5. 5 plus 7 is 12. That is our solution. When you have a combination of positive and negative, recommend that you circle them and write the negative above. Little trick to remember that is if you have a little bit of negativity mixed in with positivity, you're always going to remember the negativity. The negativity always ruins a good time. So it's negative x minus 8. The reverse of negative 8 is a positive 8. What I do on one side, I do to the other. Don't forget to bring down the negative with the x. 16 and 8 make 24. If negative 8 is positive 24, then if negative x is positive 24, then positive x is negative 24. Negative 24 is 24. 24 minus 8 is 16. 2 more. Again, feel free to go ahead of me. If you don't need me, pause it and come back to it. That's totally fine. Positive negative is a negative, so this is really x minus 7. Reverse of a negative 7 is a positive 7. I know that I'm moving the 7 because it's the one with the x, not the 13. Okay, what I do on one side, I do to the other. So 20 is x, but oops, put the variable in the beginning. That's a 20. I need to be done with this. I'm getting kind of... there we go. All right, last but not least. 2 negatives make a positive. Negative x plus 4. Reverse of positive 4 is a negative 4. What I do on one side, I do to the other. I got rid of the 4 because it's the one that's with the x, and I'm wanting to get x by itself. Those cancel out. 11 is negative x. No, wait, negative x is 11 because the variable comes first. But no, wait, positive x is negative 11 because the solution must always be a positive x. And I can check it. A negative 11 is 11 plus 4 is 15. Oh boy. Okay, again, if you need to go back and watch that again, you absolutely can, if that was not a review for you. So what you have for your homework has been written to mirror what your notes were. So if you will look at your notes, there were a total of 5 lines of problems. There's 1 on the front and 4 on the back. And there are 5 lines on your homework assignment. And so those are supposed to correspond with your notes. So let's say, for example, you're stuck on, the 3rd row, 2nd question. So you can go to the 3rd row, 2nd question, and compare them. They look an awful lot alike, don't they? How about the 3rd row, 1st question? So do you see? So they're set up very similarly, so if you get stuck, you can refer to your notes and very easily get some help. Okay? All right, so when you do this, please show all your steps. Circle the final answer. Make sure that your solution is a positive x, not a negative one, and that your variable comes first. Always challenge yourself to go back and check your answer by substituting it back in. If you need anything at all, please don't hesitate to send me an email. I'm available all the time. And happy to help if that would be good for you. All right, thanks a lot, and I will see you guys back in class. Bye.